Okay, so we're going to talk about exponential functions today, and hopefully we finish. Well, yes, probably we finish. It's not that. It's not a lot. Okay, so let's start. All right. So anyway, it's exponential functions, and then 4.2 is logarithmic functions. So why do we need to learn exponential functions? What grows exponentially? So for example, population growth follow exponential model. Radioactive decay also. So radioactive decay also follows exponential model. Yeah. So the exponential function has the form f of x is equal to a to the x. All right. So there are some restrictions on a. Well, first of all, a cannot be 0. And, a must be greater than 0. So it also includes a cannot equal to 0. A must be greater than 0. And a is not equal to 1. So if I have a 1 raised to the any number, what is 1 raised to the any number here? It's 1, so it's not an exponential function. Yeah. Now, let's graph. So what we want to do is graph f of x is equal to 2 to the x, and f of x is equal to half x, half to the x. All right. So let's see how the graph looks. So we have, let's see, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So f of x is equal to 2 to the x. So we're going to use the table. So this is x and y is 2 to the x. So what x values can I choose? Can I choose negative numbers? Yes, for x. Not for the base. So the base here, this is the base. It cannot be negative, but x, yes. Yeah, so the base cannot be negative, but the exponent, yes. So let's choose negative 2, negative 1, 0, 1, 2. What is 2 to the negative 2? 1/4, yes. 2 to the negative 1, half. 2 to the 0, 1. 2 to the first power, 2. 2 squared, 4. So you have these 5 points. So 0, 1 is right here. 1, 2 is right here. And then 2, 4 is right here. Okay. And then negative 1, half is right here. Negative 2, 1/4 is right here. All right. So this is my graph. Y is equal to 2 to the x. All right. So it looks like that. Does it have a vertical asymptote? No. Does it have a horizontal asymptote? Yes. Where is the horizontal asymptote? The y equals 0. Yeah. Okay. So we will write that in a little bit after we graph y equals to half to the x. Okay. So now the second one. All right. So this is x, y equals to half to the x. Okay. So -2, -1, 0, 1, 2. Okay. What is half raised to the -2? What is it? 2 squared, which is 4. Yes. All right. Half raised to the -1 is 2 to the first power, which is 2. Half to the 0? 1. Half to the first power is half. And half squared is 1/4. So -2, 4. -1, 2 is right here. 0, 1, and then 1, half, and then 2, 1/4. All right. So this is y is equal to half raised to the x. Okay. All right, so for f of x is equal to a to the x, can you tell me the domain and range? Range. And then we have a horizontal asymptote. What is the domain of f of x is equal to a to the x? Yes, you're right. All real numbers, negative infinity to positive. What is the range? Greater than 0, so how do I write it? You write 0 to infinity. Good. What is the horizontal asymptote? Y equals 0 or the x-axis. Yes. All right. Okay. All right. Now, let me see. So I was going to show you how the graph of y equals to 2 to the x, 3 to the x, 5 to the x look like. Okay? And also half to the x, 1/3 to the x, etc. So I'm going to Desmos.com. Yes. So can we do it now? All right. So you can see that they're almost the same. They all look almost the same. Yeah. All right. So let's see. So it's Desmos.com, and then you will click start drafting. Okay, so this is what we got before. Y equals to 2 to the x. Maybe let me make it smaller. Looks like this. Okay. And can you guess y equals to 3 to the x? How will it look? Yes, same. And then it will have the same y-intercept y because 3 to the 0 is also 1. Yes. So y is 3 to the x. Okay. Now, the next one is y equals to 5 to the x. It's also steeper, but notice that it has the same y-intercept. What is the y-intercept? 0,1, yes. Yeah. Now, I'm also going to graph y equals half x, which we already did. Is equal to half x. This one. And then the next number is y equals to 1/3. Oh, 1/3. Oh, I think they're not going to take this one. So let me just do this one. 1/3. Yes. So it's this one. Yes. So it's still the same, the domain and the range and everything. Yeah. Okay. Now, let's go back to your notes. And let's do the transformations of exponential functions. But I think you guys know, so let's need to graph it. All right. Let's see. So A. Transformation of exponential function. All right. So what about this one? Y is equal to 2 to the x minus 3. I actually need to match it up, but I need to show you. What do you think happens here? What does this negative 3 do? It's actually the same as what you learned before. What is this? Move to the right. So this is, so the basic graph is y equals to 2 to the x. So let me write down. So all of these graphs have basic graphs y equals to 2 to the x, right? This is the basic graph. Basic function or the basic graph. So what does the negative 3 do? Shift, right? How many units? 3 units, yes. So you guys know this still applies. What about y is equal to 2 to the x plus 1? Shift up 1 unit. Okay. That's right. What about if you have y is equal to negative 2 to the x? So, reflection about, yes, about the x-axis.
Wouldn't it go left if it's x minus 3?
No, it's to the right. X plus 3 is to the left. Yeah. Okay, so remember, what about this one? Y equals to 2 to the negative x. You graph this. This is reflection about the y-axis. Did we graph this function? Did we graph y equals to 2 to the negative x? Yeah, we did. This is what? 1 over 2 raised to the x. Remember, we graphed this, right? Okay, so that's why when you look back, the graph was reflection about the y-axis, right? Okay. All right. Actually, I was going to pull up. Does anybody bring their book? It's on page 336. So we were going to match. I don't know. Does anybody bring the book? If not, I have to find it online. Page 336. Number 19 to 24, maybe not. Okay. All right. So let me probably pull it up here on my. I don't remember if I have it, but let's look for it. How many people bring their book, by the way? Can you guys raise your hand? Oh, not many. Find it. No, it's in textbook. How about yours? Did you see any textbook here? See what it says. These are all the tests. So probably I don't have the Stewart book here. Oh, here, maybe. No, it's the image. Okay, I couldn't find it. Okay, no. Oh, it doesn't matter. Yes. Where's Wikipedia? No, I don't have it. Okay. I don't think we can match it, so it's fine. Yeah. So let's just continue. The next one is the natural exponential. No, I can't explain what it is. So B, the natural exponential function. All right. So if f of x is equal to e to the x. Have you heard about this? What is e? So e is it's called a natural number. What is the value of e approximately? The value of e is approximately 2.71828. Yeah. How do we get this number? This is so e is actually, so this is the definition of e, which you don't have to know, but when you get to calculus, you will know. Limit as n goes to infinity, 1 plus 1 over n raised to the n. So if you choose big numbers, maybe like 1 billion or 1 gazillion, then the value of e will be closer and closer to 2.718. But your calculator has an e value, right? Okay. So can you use your calculator to calculate what is e squared? What is e squared? So use calculator to calculate e squared, e to the negative 2, e. What value does your calculator give you? E squared is approximately what?
7.38.
Yes. Okay. And e to the negative 2? 0.13? One more decimal? 5. Okay, thank you. What is e? Your calculator value? 2.718? Yes. All right. So your calculator has those values. How do you think the graph looks? What do you think? Well, it's e. This is just a number between 2 and 3, right? Yes. So the graph will look like the others. So if you see here, probably which one is between 2 and 3? So I'm going to erase the other ones. So where is your e? E is going to be in between this. Y equals to 2 to the x and y equals to 3 to the x. So if I graph these, this is y equals The black one is your y equals to e to the x. Okay? So e is just a number. There's nothing special about it. Yeah? All right. So the next thing that we're going to discuss is compound interest. All right. See? So it's really fast until the application on the last section. All right. So C is compound interest. Okay. So for formula there are two formulas. So this is A is equal to P 1 plus R over N raised to the NP. And then the other one was A is equal to P E raised to the RT. So why do we have two formulas? Because this is for interest compounded n times per year. So this formula is used when the interest is compounded n times per year. All right. And this formula is used when the interest is continuously compounded. All right. So what does A mean? A is the accumulated value or we call it future value. So in accounting, it's called future value. Yeah. So this is the amount after certain years. All right. What is P? P is the principal, which is the initial amount, initial value. Or in accounting, it's also called present value. All right. What do you think R will represent? A yearly interest rate. And then we want to change the percent to decimal. So change percent to decimal. So usually it's given in percent, the yearly interest rate. But we want to change it to decimal. And then N, what is N? N is the number of times the interest is continuously compounded in 1 year. Okay, so if I say quarterly, how many times? Yes. How about daily? Yes. And you know the others, right? Monthly, semi-annually. What about semi-annually? Yes. Good. And the last one is P. What is P? Yeah, time. This is the number of years the amount is invested. All right. Yeah. So if you have debt, a credit card debt, what's going to happen? Your interest is also compounded. Yeah. Now, which one does your credit card use? Which calculation? Is it monthly? Is it quarterly? Is it semi-annually? Or what? Monthly? No, not really. It's actually daily. So it's always based on your daily balance. So just imagine this exponential function. If you don't control your credit card spending and then you leave the balance there, it grows exponentially. So it grows very, very, very fast, right? You know, exponential growth is faster than linear or quadratic. So it goes really, really fast, okay? So if possible, pay off your credit card balance every month, right? Yeah, if possible. Because otherwise, whatever is left over, you need to pay the interest on daily basis. Yeah. All right. So also student loan. Does anybody have student loan here? Okay. I hope not that much. Oh, okay. Oh, that's quite a lot. But is it federal loan or private loan? If it is federal loan, then the government will pay for the interest up until you graduate. So, but if it is private loan, your interest accrue the day you take out the money. So just say total you borrow 6,000. At the end when you pay, you probably end up paying a lot more. Yeah, because the interest is continuously compounded. Yeah. Cal State is more expensive than ELAC. Yeah. Okay. So anyway, let's do an example for the continuously compounded interest. All right. What is the interest rate? Our interest rate at the bank right now? Do you guys know? Does it earn interest? No, not really? Yeah, it doesn't. Okay. Now, let's talk about, I'm trying to find the interest application here. Let's see. So basically, this is review, yeah. Here. So, for example, maybe on a different page. I guess we're right now. Okay. So, for example, all right. N owes, how much do I owe? $3,000 on a credit card. Yes. So, which charges? How much is the typical credit card charge interest? What is it? No, that's the cashback. They don't charge 1.5% interest. Like, oh, that's very high. Yeah. So usually 24.95. Oh my gosh. Okay. Usually, if you get a good credit card, it's probably around 13%. So I'm going to put 12.95%. Okay. If she pays the full amount in 3 years, how much does she need to pay? So suppose I didn't make any payment in 3 years, and then at the end of 3 years, the lump sum is due. How much do I need to pay? This is 12%. This is really common. Yeah. All right. So what would you do here? Oh, if the interest is compounded, I have to give you. So assume, the interest is compounded daily. All right. daily. So which formula do I use? The first one? Yes. So A is equal to P 1 plus R over N raised to the NT. So that's the formula that I'm going to use. What am I given? 3,000. What is this? Principal. What is this 12.95%? The rate? Okay, so how do we write it down? 0.1295. Yes. And then what is this 3 years? T is 3 years. And where is my N? Daily. So N is 365. All right. So all math problems you should circle. Yeah, whatever, when you see a number, circle it because you know it will be used somewhere on your equation. All right. So let's write down. So A is P 1 plus R over N raised to the NT, and we want to find A solution. So the P is 3,000, 1 plus R over N. So we have to use calculator here, right? Divided by N. N is, what is N? 365 raised to the 365 times 3. All right. Okay. Now, when you calculate these, I think it's easier to calculate it as one shot, like all the calculation in one step. So try it on your calculator. So 3,000, so in my calculator, I'm entering 3,000 and then multiply by, open parentheses, or mine doesn't have to multiply by, 1 plus 0.1295 divided by 365, and then raised to the 365 times 3. All right, what did you guys get?
4,043.9.
Yes, so 996, so it's actually 4,424, isn't it? Okay. All right. Wow, so after 3 years, instead of having to pay 3,000, you have to pay, how much is the interest? Which one is the interest? Which one? No, what is the interest? What is the amount of interest? How much dollar is the interest? 1,424. Yeah. So notice that it's close to 1,500. Look at this. This is your principal. This is the amount you borrow. And the interest is 13% per year. But look at how much interest do you have to pay? 1,400. So that's close to half of the 3,000, right? So it's close to 50%. So that's the power of compounding effect. Even though it's 13% a year, after 3 years, it's going to be a lot more. Yeah. Okay. So be careful if you have loan or credit card loan or any loan. Yeah. Maybe right now when you buy a car, you probably pay monthly, right? But it's actually a better idea to pay it in full. So it's the scientific calculator. This is 20 minutes. Thank you. All right. Now, let's do another problem. Yeah, in 3 minutes. So, but it's not related to interest. Let me see. This is easier because the formula is given. So later on we will discuss more formulas. So number 2. So a skydiver, oh, this is skydiving. Skydiver jumps from a reasonable height above the ground. The air resistance she experiences is proportional to her velocity. All right. Okay. So the downward velocity, so it can be shown that the downward velocity of the skydiver at time t is given by V of t is 80 times 1 minus e to the negative 0.2 t. All right. So t is in seconds, and v of t is feet per second. What is the initial velocity? So that's the question. And then B, find the velocity. All right. The velocity after 5 seconds and after 10 seconds. All right. And then you need to draw. Well, we will use the decimals. Okay. And then find the maximum velocity. All right. What is the initial velocity? How do you find that? This is easy. Yes, so this is your equation. What is the initial velocity? When I say initial, what does it mean? V is equal to 0, yes. So V of 0 is equal to 80 times 1 minus e to the 0, right? Because negative 0.2 times 0. So what is the initial velocity? 0. So 80 times 1 minus 1. So this is 0 feet per second. So the initial velocity is 0, meaning no velocity. Yeah. How about velocity after 5 seconds and after 10 seconds? Yes, so you have to calculate V of 5 and V of 10. That's what you need to calculate. So V of 5 is 80. 1 minus e negative 0.2 times 5. Can you give me an approximate value here? And then V of 10 is 80, 1 minus e to the negative 0.2 times 10. And give me an approximate value here. So 80 times 1 minus e to the, where is my e? E to the what is negative 0.2 times 5? Yeah, negative 1. So what is approximately 50.57? Did you guys get that? 50.57 feet per second. And then V of 10 is 80 times, I'm almost done, 1 minus e to the negative 0.2. All right. What's the answer? Oh, mine is, let me see, 80 times 1 minus e raised to the negative 2, not negative 0.2. Right. Yes, 69.117 feet per second. How do we draw? Well, you use the graphing calculator, right? Okay. Should I do it? Yes? Okay. No? Almost done. What was the formula? Y is equal to... Let's erase this. Erase this. Okay. Y is equal to 80 multiplied by, 80. Multiplied by 1 minus, 1 plus minus e raised to the negative 0.2 x. That's it. Is that right? Oh, how come it doesn't draw it? Yeah, so it's going to look like this. So what do you think is the maximum velocity? It looks like this. What is the maximum velocity? 80, yes. Yeah. So the maximum velocity is 80. Yes? Okay. Good. All right. Where is this? Yes. So draw the graph. So this is decimals.com, and the maximum velocity is 80. What is the unit? Feet per second. Yes. All right. So how do you get the maximum velocity? From the graph. Yeah, actually, you could look at it from your equation also, but you can get it from the graph. Okay, guys. So tomorrow we will start 4.2. This is the beginning. So basically, the formula is available and we can start using it. In the next sections, around the end, you'll see more interesting applications. Yeah. This is just using the formula. So the class is on Wednesday. Yay. Okay. All right. So I'm actually also glad that I got to give you extra credit. Aren't you glad you're going to get at least 5 points? Well, actually, at most 5 points. Yeah. Okay. Good. Okay. So see you tomorrow. And tomorrow we will review the sample test. Yeah. Not the whole day, but 30 minutes. So prepare some questions on the sample test and ignore number 16. All right. So let me save this. Save. Oh, okay. Oh, maybe the whole email system wasn't working. The server's not working, blah, blah, blah. Okay, that's why. Okay. So you're able to do it. Okay. 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 Good. Thank you. Bye-bye. Aye. Did you guys were you guys able to do it? The exercise? I think next was here's how about you. The exercise? The one you turned in today? Were you able to do it? Oh, okay. 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 All right. Okay, so we're done with 4.1 exponential function, so we will continue with 4.2.